Hello everyone, this is Team 24059, the Dynamic Darts, and today I'm going to be going over how we can code for prop detection in FTC. We will be using the OpenCV library for image detection. Be warned, this is not an in-depth guide to OpenCV, but rather for those who already have a basic understanding of Java and the OpenCV library. So to start off, we're going to create two matrices. Matrices are accessed through the mat class, which are basically a class within the OpenCV package. And essentially what these matrices are a way to represent and work with image data. Each element in the matrix corresponds to the intensity of a pixel in an image. So here we're creating a submatrix and an HSV matrix. HSV matrix is used to detect saturation and color. Now below this we have our get average saturation method, and basically what this does is it calculates the average saturation of a specified rectangular region within our matrix. Now here we have the Vision OpenCV method, which is going to be the bulk of the code that performs the detection. So we're going to start off by creating a variable to represent our camera. So here I've named my camera Vision Portal, but you can name it whatever you'd like. It's really your choice. And here we have these two variables. So what satrect left is it's basically measuring the saturation that the camera detects in the left field of the camera. And here satrect right detects the amount of saturation found on the right of the camera. And below this we have satrect none, which refers to saturation that the camera would detect when there is no prop in the camera, like in front of the camera. So if you didn't place a prop in front of the camera, it would return 40, and this value can be changed based on like your camera, so it's completely personalized, but 40 is just what worked for us. So now vision.opencv just gets the hardware map and initializes the camera. And here we have satrect of camera mid, which is basically calling the get average saturation function and measuring the average saturation of the left of the camera and the right of the camera, and it's setting the saturation rect left of camera mid equal to that value. Now here is where the majority of the math for the detection is done. So to understand how this works, we first have to understand what saturation is. So to put it simply, saturation is the amount of color detected within an area. So we'll be detecting our prop by measuring the amount of color in each field, like in the left or the right, and then we'll be comparing it to see which section actually has the prop. So basically what this is doing is it's checking, so if the saturation of the left of the camera is greater than the saturation on the right of the camera, and the saturation on the left of the camera is also greater than the saturation when there is no prop, then we're going to return, oh, I found the prop on the left side of the camera, which is what this line does. And basically the same concept here. If the saturation of the right of the camera is greater than the saturation on the left of the camera, and the saturation on the right of the camera is also greater than the saturation when there is no prop, then we're going to return that the prop was found on the right side of the camera. And if neither of these if statements are true, then we're gonna do else, return that there was no prop found, and that's what this line is. So that basically sums up our code, and I hope you guys found this helpful, and thank you for watching.